all of you are ready, and I'm going to continue now. Okay, yeah, fine. Now here we were discussing the binary search. Okay, and this is the logic of the binary search. What we do, we the binary search logic is this. Okay, right? And here what we do, return the position where the search element was found, right? Now here, to understand to know the efficiency, please note we are using while loop here. Okay, in fact we can use do while loop also. The more precise one will be do while loop. Anyhow, now I want you to pay attention. Let's continue. Yes, now we are discussing the efficiency of binary search. See, please note in the previous cases where we found the efficiency of linear search and bubble sort, insertion sort, etc. There we depended on the number of iterations of the loop. Okay, try to understand. The outer loop used to work for n times, and the inner loop used to work for some n into n minus 1 by 2, something of that sort. In insertion sort, again the outer loop worked for approximately n times, and the inner loop, though the number of iterations were unknown, sometimes it used to be 0, sometimes it used to be I, so it used to be I by 2, etc. Now in this case, in binary search, as you see, there is only one loop, there is no nested loop. Okay, so now since there is no nested loop and the loop that we are using is loop, so here now as you can see, we start with n elements. In the first iteration of binary search, please note, in the first iteration of the binary search, how many elements will be there? N element would be there, right? In the second how many elements will be there? In the second iteration of the binary search, there would be n by 2 elements, isn't it? Why? With every iteration we are cutting down exactly the half area of the search. That is, exactly half search area is cut down, is omitted, right? And in the third iteration of binary search, there would be n by 4 elements. So like this, in the last iteration, we would have only and exactly one element. Okay, right? In the last but one, there would be 2 elements, isn't it? Right? Okay, understand this. Okay, right? There would be 2 elements. Okay, isn't it? We start with n elements, and then there would be, in the first iteration, n elements would be there. In the second iteration, we will have n by 2 elements, n by 4, so on. What we will have in the last but one, there would be 2 elements. in the last but two, right, in the last but two iteration we would have 4 elements, correct, isn't it, in the binary search, right? I hope you are trying to understand this. Okay, if you have not understood this, no problem, I'm going to explain it to you again. See, when we are starting with the binary search, okay, right, say this is the array, okay, in the next there will be exactly half of the area, in its next again half of it, in its next again half of it, correct? So like this, as you can see here, there will be only 4 elements, only 2 elements, and only 1 element, okay, right? So this is how the binary search would work. Okay, so now come again, what we will do come again, here what we will do is we'll try to understand this more easily. Now what were the elements in the first iteration? N. In the second iteration, n by 2. In the third iteration, n by 4. In the fourth iteration, n by 8, isn't it, right? Okay, so this is how the elements would be in the list in each iteration of the loop of the binary search, so until 4 2 1, isn't it, 8 4 2 1, right? Okay, this is how the elements will be in the binary search loop, okay, well, that is in the while loop. Okay, so now what is that I'm trying to tell you here is, please note, we actually want the number of iterations of the loop, but it is while loop. Okay, so in the while loop we have put the condition low less than or equal to high, isn't it? Okay, please go through the condition. It is low less than or equal to high, as you can see. Okay, right, once low becomes greater than high, then the loop breaks. Okay, right, so I mean to say the search element is not found. Okay, when low becomes high, so I mean to say there is only one element that we have to search. Okay, only one element is left in the array. Okay, so now here, so we don't know the number of iterations, but we are trying to find the number of iterations. Okay, so now come here, assume the number of iterations x, assume the number of iterations as x. Okay, so now what is this? N is the number of iteration, n is the number of elements in the array in the first iteration, n by 2 is the number of elements in the second iteration, n by 4 elements, that is half of this, is the number of elements in the third iteration, n by 8 is the number of elements in the fourth iteration, and so on, correct? Okay, right, so can you people tell me what might be x, or is there any relation here? So what is x? X is the number of iterations. Okay, right? Okay, so as you can see, 1 is nothing but, say, 2 power 0. This is 2 power 1, 2 power 2, 2 power 3, so on. So this will be what? N equals x, that is 2 power x. I hope you have understood this. Okay, n equals 2 power x. How come? Come again. This 1 is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, so on till 2 power x is n, isn't it? 2 power x is n. Okay, so 2 power x is n. So what is x? What is x? X equals log of n to base 2. Okay, log of n to base 2. So the worst case efficiency of binary search is log of n. The best case is definitely when the search element is found in the first iteration itself, that is log of 1. Okay, so now come here, let's go here and let's write worst case efficiency of binary search is log of n to base 2. Okay, right? Average case efficiency would also be the same of binary search is log of n to base 2. What is n here? N is the number of elements in the array. Okay, in the search area, the number of elements in the array. Okay, and what is the best case? Best case efficiency of binary search is log of I'm sorry, big O of 1. Okay, right? So what is the worst case efficiency of binary search? Big O of log n. Okay, average case log n, best case big O of 1. Okay, now I know that you have some doubts. Okay, that is you have not clearly understood, so I'm going to explain it to you again. Please note, when we start with the loop, that is while loop here, okay, when we start with the loop, okay, how many elements will be array? There will be n elements. In the second iteration, okay, what we are doing, see the first half of the array. Okay, the first half of the array, the first half of the array or the second half of the array. Okay, the first half or the second half. Okay, we are cutting down, I mean to say we are removing it from our search area. With every iteration, exactly the half of the search area that is at that point of time will be reduced. Okay, right? So you mean to say exponentially the search area is going down. Okay, so n, next iteration the search area is n by 2, next iteration the search area is n by 4, next n by 8, so on till 8 4 2 1. Okay, in the last iteration there will be only one element where low will be equal to high, when low will be exactly equal to high. Okay, right? So now n equals what is that we want? We want the number of iterations, because we calculate the efficiency on the number of iterations only. But since it is while loop, when do we use? When we don't know the number of iterations. Okay, so here we have to guess the number of iterations. So let us guess it as x. Let us assume it as x. Now what is x, or what is n? N in terms of x or x in terms of n? What can we do? N in terms of x is easy. How come? 1 is nothing but n power 0, n power 2, n power 3, so on n power x. What is x? Number of iterations. Please note here, this is one iteration, second iteration, third, fourth, dot 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 dot, x minus 3, x2, x minus 1, x. So x iterations are there. So x is in terms of n equals 2 power x, isn't it? 4x, this is 2 power 0, 2 power 1, 4, 2, 2 power 3. Okay, so on till 2 power x is n. So with this, okay, push that 2 power on the LHS, we get log. So x equals log of n. Okay, I hope you have understood how to get the efficiency of binary search. Okay, knowing the efficiency of binary search is very interesting. So I hope you have understood this. Okay, fine. Now let's move on with our next next topic. Our next topic was binary search, structures and object oriented programming. So now we are going to start with structures. Okay, fine. So the new topic is structures. So now here what we are going to do now is we are going to start with structures. I want you to pay attention and learn. Okay, so now we are going to the next level of our training. Okay, we are starting with structures. What is a structure and why do we need a structure? See, in real life we have so many examples like student, like employee, like ticket, like a bill, okay, or like a product. When we say, it might be any product, it might be, you know, some utensils, it might be electrical like appliances, it might be electronic gadgets, it might be mobile phones, it might anything, it might be even you know, in a mall, or say in a big supermarket. Okay, we get variety of items, anything there is a product, correct? Okay, right? Okay, etc etc, we can take n number of examples like this. Okay, so now student mean to say a student will have name, a student will have USN, a student will have his or her marks, will have semester, correct? Okay, semester or year, which year studying in, branch, etc. Employee means employee will have name, year, employee ID, okay, employee salary, employee designation, okay, employee domain, etc etc. Okay, right? A ticket means have source, it will have destination, it will have price, it will have source, destination, price, date, etc etc. Okay, bill. A bill will have ID, a bill will have date, a bill will have amount, okay, right? A bill may have customer ID, okay, etc etc. A product will have product name or title, okay, right? Okay, it will have product ID, product type, what kind of you know, product it is, its price, okay, and a category, okay, etc etc. Now take a book. Okay, a book will have it will have author name, it will have ISBN, okay, it will have price, okay, it will have publisher, okay, etc etc, isn't it? Okay, so now let us take one example at a time. Okay, one example. Now here what I do is I want to store the name. Okay, okay, let us take one example, that is say of the student. Okay, right? Okay, so of the student, when we are saying the name, if I want to store, I know it should be a string. So name of let us say it is maximum 30. Now USN it is alphanumeric, so alphanumeric is also okay, character, like it will be stored as a string. Marks might be of type float, okay, and semester will be int, and again branch will be okay, some. Okay, so now as you see here, what you have to observe here is, this you already know, but what is that you have to observe carefully is, please note, either the data type of the fields, these are called as fields. Okay, please note, the student, employee, ticket, bill, product, book, all these are called as entities. Okay, right? They are real life entities. Okay, right? Or real life concepts or real life objects. Okay, right? These are the different terminologies that we can use. Now name, US and marks, they are all fields or attributes of the entity. ID, date, amount, customer ID, okay, will be the fields or attributes of the bill, okay, and so on. So here, as you can see, the attributes, their data type are different. One is float, one is int, one is char. Even if the data type is same, say char, their sizes might be different, okay. That's what the difference you have to observe. The name and USN, though they are of type char, one is of size 30, one is size 15. Now, that is the first observation. Second observation that you have to do is that please note that here all this data is required stored together, okay. All this data has to be stored together because it is representing the details of one entity, okay. It is representing the details of one entity, okay. So storing them together, binding them together is very important, okay, right. See, when we go to a college, okay, we have books, we have pen, we have maybe some pen box, that is geometry box or something. We may have our wallet, okay. In the wallet we keep uh, the bus pass, or say our college ID, or some money, okay, right. So now all this we carry almost daily together, isn't it? We carry them together daily. So there should be a way to store all these things together. That's the reason we have the school or college bag, isn't it? We have for this reason. Say I am a trainer, okay, right. So I have to I don't usually carry but a laptop for sure. So I need a bag that will help me to carry a laptop. So there should be a compartment to keep the laptop, correct. Now if I'm going on a trip and I need say some important tools like a scissor, like a cutter, like a matchbox, okay, etc., like thread. These are all the things, which we may need in sometimes urgently. So please note here that, so I need a traveler bag, so that will have so many compartments to store the clothes, to store uh, the the tools separately, the money separately, okay, water bottle separately. So all this, so that makes a traveler bag, okay. So in this way, here when we come back, so all these things like say name, USN, marks, semester, branch, say if we give some values to it, they represent the values of one person. These are all these values will be the values of some person. Take one more copy of all these values, that will be an the details of another person. Take one more copy of all this, say separate name, different USN, marks, sem, branch. So they will all be the details of a particular student again, okay, isn't it? So here we are representing one student, a particular student. So keeping the details of all these fields together becomes necessary. So we have structures. See, in array also we store the different together, but in the case of an array you have to observe that the size and the data type of all the elements are same. But in the case of structures, as you can see here in all the examples that you can see, either the data type or um, say either the data type or the size is different, okay. So that's the big challenge, okay. Now let's see the differences between array and structure. Okay, all right. Now in an array, what? All the elements of an array will be of same data type. Okay, will be of the same data type. Okay, right? Okay. However, in case of structures, the fields, nothing but elements only. Okay, or members or attributes. Okay, you can use any of these terms: element, member, field, attribute, any of these four. The fields of a structure may or may not be of the same data type. Okay, then all the elements of an array will be of the same size. Here the fields of a structure may or may not be of the same size, right? One will be of 10 bytes, other will be of 5 bytes, or 4 bytes, one will be of 8, etc, etc. Okay, right. So please see that all the elements of a structure will be of the multiple of 2, 4, 8, like that. Okay, right. So here what will be the good size? Here where did we write it? Yes, here it should not be 30, let it be 32, and let this 16. So that is good idea. Okay, right. And let this be, it is of 20, make it 24. Okay, right. Okay, so that all this are multiple of 8 or at least 4. Okay, that is how it should be. Now next is we'll continue with the differences. Okay, all the elements, okay, will represent the same data of different objects. Okay, the fields of a structure represent different data or information about the same entity or object. Okay, so this is very important. All the elements will represent the same data of different objects. Example, all the ages of the students of a particular class, all the salaries of the employees of a particular company. Okay, here on the array side, here say the different fields of a structure and different data about the same object. Say one will represent the name, one will represent the age, one will tell the salary, one will tell the designation of the same person, of the same object. Okay, right, this is very, very important. Okay, right. Now next, what are the similarities? All elements of an array all elements of an array are stored in continuous memory location. Okay, here also it is the same thing. All the fields, okay, all members or fields, okay, or attributes of a structure variable, are stored in contiguous memory locations. Okay, then what are the other similarity? to access a specific element of an array, we use a subscript with an index. Here, to access a specific member of a structure, we use dot operator. Okay. All right. Array versus structure. Okay, so I have saved this so that I can share it with you. Okay, right. So these are the differences and similarities of, okay, right. We can have we can create an array of structures. Okay, we can create a structure with arrays as its members. Example here we have done it. See here the structure is having arrays. Okay, name here is an array, USN here is an array, branch here is an array. So a structure can have arrays. Okay, or a array might be made up of so many structures. Okay, right. So that will be array of structures. All right. So now again continue. If you want more, what we can do, we can have an array of arrays. We can have a structure within a structure. Okay, right. And then we can create a pointer to an array. We can create a pointer to a structure. Okay, pointer uses to access the elements of an array. Okay, pointer uses arrow operator to access the elements of a structure. Okay, right. Okay, so these are the differences and similarities between array and structure. Okay, so see, very importantly, what you have to simply remember is, out of all this, okay, see, otherwise I can write another 2-3 points also, but that is of that won't be of much significance. Okay. So here what I am saying is, the major difference between array and structures and the similarity is that, first, the similarity I'll tell you, all the elements of a structure and an array, whether it is a structure or array, stored in continuous memory location. Okay, so that is one thing you have to note. And what is the difference? The difference is very simple. All the elements will be of the same data type and also same size. In the case of a structure, all the elements of a structure may or may not be of the same data type or same size. Very simple. That's it. Okay, right. So that's it. I'll close this. Okay, fine. Now let's continue. Let's come to the structures. I'm explaining you in very detail, so please pay attention and learn. Okay. Now, how do we bind this? Is we have to use the keyword struct, and that is the the rule. Okay, struct, give it a name. Okay, what it is, it is student. So okay, right, it is student is the name that I have given. Now this is called as structure definition. What I have selected here is structure definition. Okay, very important. This is structure definition. We have defined a structure. Okay, when we define a structure, please note, when we define a structure, when we define a structure, we create a data type. Thus it is also called as user defined data type. Okay, user defined data type, or simply abstract data type, or derived data type. Okay, so this is derived data type or abstract data type. Okay, or user defined. Okay, user defined data type. Okay, I hope you have understood this. Okay, fine. Today's date is 21st. Okay, 21st Feb, session 8. Today's session 8, right? Okay, and okay, fine. Okay, so now let's continue. I hope you have tried to understand whatever I'm trying to say here. Please note, whenever we create a structure, we create a data type. Okay, so student here is a data type. How come? I'm sorry, how come student is a data type here is, please note, now that we have created a structure, let us use it. Say student S1. So what is S1 here? S1 is a variable and type. How it is similar? Very simple. Float F. So what is F? F is a variable of type float. What is S1? S1 is a variable of type student. Very simple. Okay. What is the size of F? It will have some size in memory, that is 4 bytes. What is the size of S1? It will have some size in memory. So for that you have to simply count it. So 32 plus 16 is 48. 48 plus 4 is 52. 52 plus 4 is 56. 56 plus 24 is 80. Correct. So the size of the student type is 80 bytes, or the size of S1 is 80 bytes. Okay, I hope you have understood. I hope you have understood this. Okay. Yeah, if you have any doubt you can ask me. Right, I'll check if there was any doubt. Yeah, you have not asked any doubt, so let me continue. Okay. Okay, fine. So now let's continue here. So please note, as I said, S1 is a variable of type student. Okay, so as F will have some characteristics like what is its size, what is the range of values it can store. Okay, right, and within the memory it will be stored. Also like this, for S1 also we will have all the properties. Okay, so but S1, that is of type student, who created student data type? It's we who created, so it is called as user defined data type. Okay, right, all right. So here let's continue now. Now next, What is that I'm going to teach you now is, please note, in this, okay, right? So this is what a definition of, this is the definition of a particular structure, okay, called as structure definition, okay, right? And this is most important note, a structure definition will not have, okay, right, a structure definition will not have any memory allocation, okay, right? Memory is allocated only for the variables that are created, only for the variables of the structure type that are created, okay, right? The next, a structure definition will not have any memory allocation, okay, right? Okay, this is very important. Why? Because by defining a structure, we are telling the compiler the details of a, we are telling the details of a structure, okay, and hence there will not be any memory allocation, okay, right? The structure definition, that is this one, okay, right, will not have any memory allocation. Why? Because by defining a structure, we are telling the compiler the details of a structure. So what is the details? We are telling that, see, dear compiler, the student is the name of the structure, the name here is the first attribute, its data type is char, its size is 32 bytes. The USN, its data type is char, 16 bytes. Marks, its data type is float, size is 4 bytes. Sem, its data type is, it is the fourth attribute of the structure. Our name is Sem, data type is int, size is 4. Fifth and last attribute is branch, its data type is char and size is 24 bytes. This is what we are telling the compiler, okay. So there is no memory allocation. So when there is no memory allocation that happens, so I cannot say here, okay, right? So I cannot say sem equals, remove that semicolon, and I will say sem equals, say sem equals 2, second sem, fourth, okay, right? So I cannot do this, this is wrong, okay. Assigning some value here inside the structure is wrong. I hope you understood why it is wrong, because inside the structure definition there won't be any memory allocation at all. So then when the memory allocation happens, is here, okay, here, student S1. So memory allocation happens for the variables, that is S1. Did you understand? Memory allocation happens for S1. How many bytes? You just simply go and count the size of every member, sum it up, that will be the size of S1, okay, right? So one more one more similarity between array and structure is, the size of an array is the sizes of all the elements of the array. In the case of structure also same thing, the size of a structure is sum of the elements of the structure. Very simple, okay, right? So I hope you have understood so far. Now let's write a program and try to understand the other things, okay. We'll say program 2, I think this will be program number 21 or something, p21.c. program to illustrate the use of or working of a structure, okay. Okay, so then we will say int main. Here before that define a structure struct. Now we'll take different employee struct employee name of 30. Okay, as I said, it should be of 32 or 24 or 16. It is better if it is like 2 4 8 16 32 64. So if you want to increase 32 to 40, do not make it 40, make it better make it 64. Okay, right? Okay, so name is 32. So even if you make it as 29, say 29 30 or something, 28 29 30, all this. Okay, so the compiler itself will do the padding. Okay, right? What is padding? I'll explain you with the example itself. So now name, and we will have this, the data type is what? Char, and char employee id, then float salary, correct? Okay, then again char designation. Okay, I'll simply give designation okay, right? So designation, we will store it as only acronyms. Okay, yeah, so it is AE. So AE means associate engineer, and then SE means software engineer, SSE senior software engineer. Okay, TL tech lead. Okay, right? PM project manager. Okay, right? PL project lead. Okay, DH delivery head. Okay, right? So these are the say the designations we use in an IT company. Okay, so let it be like that. Okay, now you have to give a semicolon to the end of the definition. Now what we will do, we will create one employee E1. Now I want you to observe here, I have made the first letter capitalized. Okay, so that you should observe, and always capitalize the first letter of the first word of the structures. Okay, right? Okay, that is the standard practice in the industry. Okay, otherwise you can give E as small also. Okay, now not just that, here we can initialize also. See, we can also initialize. How to initialize? Say name I will give Madhav. Okay, ID say AS 2018 2018 101. Okay, something like this. And then salary 23,455. Then designation, say associate software engineer, ASE. Okay, right? Now we can initialize structures like this. Okay, right? Now what we'll do, we'll create one more employee E2. Okay, now what we'll do, we will first print the employee 1 details. So employee 1 details are, okay, what we'll do, slash n we'll print it percentage, we'll say name equals percentages slash n. Okay, right? Designation equals percentages. Okay, and if you want to print some other details, you can say ID equals percentage s, correct? Okay, right. So here what we'll do, observe here, we have to use dot operator, even dot name. So here what we'll do, we will use some 20s, 20s, 20s. Okay, what is that? It will do formatting. You will understand it. Even dot designation and even dot id, correct? Okay, here we will say return 0. So what we did, we are simply printing the employee 1 details. Okay, right? Employee 1 details are, okay, let's run this. Yeah, there is some error. Let's try to remove. Okay, since we have given the name as .c, we have to use the keyword struct, and here also struct. Okay, right? Now save this, run this. Yeah, so now again there is an yes. So this is ID of, let us make it something 10. Okay, now run this. Yeah, so as you can see, it is not printing properly, so let's make it, okay, let it get printed properly. Okay, so this is 20, it's too big, I think so. Let's make it 12 slash in here. Okay, 12. Now let's run this again. Yeah, as you can see, designation name, yeah, okay, right. I hope you have understood this. Now that 20 as this also we have to print it separately, only then I can make you understand. Okay, yes, so this is 4 1 2 3 4 5 6 7. Yeah, now can you see it? It is now aligned, right aligned. Okay, right, it is right justification, right aligned. Okay, so I can simply say 16 and 9 18, so this will be even more good. Yes, some extent it is more good. Okay, right, so name, designation, id, Madhav AAC, and it is printing the details. Okay, fine. Now next, so here what we did, we have created one structure. Please note, I cannot give the value here. Okay, say 34,500.5 f. Okay, we cannot give, say, compile this, it will be an error. See, it is giving error at that line. Why? Because there is no memory allocation that is done for the definition. Okay, for this definition there won't be any memory allocation. Memory is allocated for this even. Okay, right? Okay, so you cannot give or say assign values here. So you cannot say name equals Madhav here. Okay, this is also wrong, right? Compile this, the size of the variable here. Okay, size of even equals percentage D. So what we'll say, size of E1. Okay, now count the size of this. So this is 29 plus 10, 39. 39 plus 4 is 43. 43 plus 5 is 43 plus 5 is 48 bytes. Correct? No? So it should give 48, but what it will give, let's check. Okay. See, size of E1 is 52, it is saying. Okay. It is here 48. 29 plus 10, 39. 39 plus 4, 43. 43 by 48. Right? Okay. But it is saying 52. Okay. So it is doing 4 bytes padding. Okay. So why it is doing that 4 bytes of padding is to make every element of the structure to a multiple of 4 bytes. Okay, so to make it a multiple of 4 bytes, what every structure element should be of 4 bytes. So this is 29, right? So actually it will give 32 bytes size. This is 10, so it will give 12. Okay, so this is 8. So that's how it tried to make it. Okay, right? So this is 4, which is correct. So here 12 plus 12 is 24 plus 36. Actually it should be 56, but it is somehow adjusting it to 52 bytes. Okay, but if you try to run this on some latest compilers, you will see that the size will be 56 bytes and not even 52. Anyhow, you count the size here, 29 plus 10 plus 4 plus 5, it is 48. But when we saw the size of even if you give the size of struct employee here, so it will give 52 itself. Okay, can you see size of E1 equals 52? Okay, if you are getting confused, let's use the /n. Okay, size of E1 is 52, whereas if we count, it is 48. So it is doing 4 bytes of padding. Okay, right? I hope you have understood this. Okay, all right. So 29 it is doing 29 it is making it 32, and 5 it is making 6. Okay, so totally 48 it is, it is making it 48 bytes, which is a multiple of 4 or 8. Okay, so that's how it is doing the padding. But actually padding should happen for every element of the structure. So I hope you have understood what is padding. So padding is done for faster accessibility, for faster reading and writing of the structures. Okay, see, if it is 29 bytes, one is 5, one is 10, so what happens, the buffer has to keep on changing every time. So what happens, if we make it a multiple of 4, every element of the structure multiple of 4, faster reading and writing can happen, because the buffer size we can fix it to 4 bytes, 8 bytes. So it will keep on reading so many number of bytes, okay, without having to change its size, okay, every time. That is the benefit of padding. Okay, now let us talk about copying the structures. We can copy the structures like this. Okay, E2 equals E1. So now you say employee 2 details are, okay, employee 2 details are, you simply print, and here you say E2. Okay, right? Now run this. So as you can see, it has copied all the data. Okay, isn't it? Right? Okay, now you go and change some value, and here you make it SSE. Now run it. So can you see that the values are same? Okay, right? So look at the benefit of the structures. You can copy the whole structure, okay, right, at a time. Okay, but if I want to copy one by one, that is element by element, I don't want to copy all the elements, I want to copy only the salary, or I want to copy only the designation. So how to do it? Very simple. E2 dot name, e2 dot name equals e1 dot name. I cannot write. The reason is the name here is an array, so I cannot copy the array like that. So I have to use strcpy. Okay, strcpy of. So now this is okay, right? So I want to copy the designation. So you can say designation. Okay, you want to copy the ID. ID we usually don't copy, correct? Okay. I want to copy the salary. It can be easily copied. E2 dot salary equals E1 dot salary. Okay, right? Okay, so this can be done. Okay, and we can say here E2 dot ID equals. So here also we should use strcpy. ID we have taken it as string. Okay, e2 dot id. So we will say TL tech lead joined in 2015 and ID is 056. Okay, so this is fine now. Okay, so now you cut and paste this. So what did I do? What did I do? I do not wanted to copy the structure at a time. I want to copy it piecemeal, that is attribute by attribute. Okay, right? Piece by piece. Okay, so now run this. Yes, this is good. Yes, as you can see, so the names are same, only the IDs are different. Okay, right? I hope you have understood this program. Okay, so what did we learn so far? We have learned the structures. In the structures, where do we use the structure? When we have to bind the data of different data types or different sizes, we use structure. Okay, all the elements of a structure are stored in contiguous memory location. Tomorrow I will show you the physical view of the structure. Okay, right? That is the diagram I will write for you. Okay, and then the structure definition, there won't be any memory allocation. Okay, memory will be allocated only to the variables of the structures. Okay, right? And a structure can be copied just by saying structure 1 equals structure 2, as you saw. To access the elements of a structure, we have to use dot operator. Okay, right? We have seen the differences between arrays and structures, and before that we also discussed the efficiency of binary search, and finding the efficiency of binary search was very interesting. Okay, I hope you have enjoyed the class today, and tomorrow what is that I'm going to do is structures I'm going to continue. Okay, right? And then object oriented programming. Okay, right? And then the constructor, so string handling functions will be pushed to. Okay, so I hope you have enjoyed today's class. It was very important. You know now many things about the structures, and we are going to continue this. So tomorrow we are going to pointer to a structure within a structure, and then we will jump on to object oriented programming, and we will there I will explain you some terminologies, and then we will start writing the programs in C++. Okay, yeah, thank you all.